Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Haris bin Awaka. Today, I'm going to present about sport biomechanics video analysis. The topic is long jump. Okay, meet my friends, which is Anis Anina binti Samhan, Muhammad Hazim bin Muhammad Kamal, Muhammad Sofi bin Azmi, and Siti Nur Arsyah binti Ismail. Okay, first, we go to the introduction of the skill. Okay, before we move on to the introductions, let me tell you a bit about the history of long jump. So, the origin of the long jump could be traced to the Olympic in ancient Greece. When athletes carried weight in each hand, this was swung forward on takeoff and released within the center of the jump during a beat to increase momentum. The long jump, as we all realize today, has been an element of the Olympic since the first game in 1896. The men's event has seen some long-standing world record by US jumpers. US jumper athlete jumped 8.30 meters in 1935, a distance that wasn't exceeded until 1960. And Bob Beamon flew bent on 8.90 meters within the rarefied air of Metropolis at the 1968 Olympic Games. The latter mark stood until Mike Powell beat it with a leap of 8.95 meters at the 1991 World Champions. So, long jump is an athletics, Olympic-style sports occasion where competitors join speed, quality, and sprightness in endeavor to land as long way from the take-off point as could be expected under the circumstance. There are 4 stages that involved in the long jump technique, which is first stages is approach, run, up. Then second, take off. Third, flight through air, and the fourth is landing. Okay, competitors sprint along a runway and jump as far as possible into a sand pit from a wooden take-off board. The space travel from the sting to the board to the closest indentions within the sands to that is then measured. So, if an athlete step beyond the board, a fault is committed and the jump isn't measured. Most championship competitions involve 6 jumps per competitors, although usually variety of them, those with the shorter marks are often eliminated after 3 jumps. If competitors are tied, the athletes with the subsequent best distance is asserted the winner. Okay, next we can see some video. So this is this show the video when an athlete run along the runway and do the jump. So as you can see, there is a run phases and the takeoff and also fly on the air and landing phases. Okay, next we move to the muscle involvement. So the muscle involved in long jump is core strength, which is long jump have to work the hamstring, thigh, back, abs, and hips, and also glutes for a strong long jump. A robust core helps an extended jumper maintain body control, so as to utilize all the muscles power throughout the body. The core transfers strength and momentum through the shoulders and arm, yet as within the lower body. So as you can see, hamstrings, thigh, backs, abs, hips, and glutes are the core strengths that long jumper needs to improve and forward. So the next muscle is the hip power. The hip strength is important for long jumps because they have to be able to run fast and use the hip strength to drag their body up and forward during the landing. So if an athlete do not have a hip power, they won't be able to run fast and they can't use the hip to drag their body up and forward during the landing. So next is shoulders and arm. So when watching a protected jumper, you may see the shoulders and arm are worn to drive and supply momentum in both running and lifting the body within the jump. So, shoulders and arms also play an important role in the muscle involvement. So, next we go to the bone and joint involvement. So, during the process of sprinting, the major bone works together as joint, which facilitate the movement of the body. The ankle, along with the tibia and heels bones, are the hinge joints. So we have hip, femur, and pelvic bones, which is they use it when they are on the air and to get a momentum to uh, move more further. Okay, next we go to the joint. Long jumps are also involve movement in the knee joints, with the femur and tibia acting as a hinge joint. Quadricep muscles are used with extensions of the joint, and gastrocnemius muscles between the knee and ankle are used in plantar flexions. Okay, next we move to my friends, Masofi bin Azmi.
So next is lever system. What is lever system? A lever system is a rigid bar that moves on a fixed point called the fulcrum when a force is applied to it. And in lever system, it should have three things, which is fulcrum, force, and load or resistance. Lever system has three types or classes with a different size regarding to what movement we do or what sport we play. So in the sport long jump event, they use the second class lever, which means lever position with the resistance between the applied force and the fulcrum. And basically long jump is involving a movement of running and jumping. So this movement use totally leg as a lever. As we can see on this picture, the feet of the toes are actually act as fulcrum, and the gastrocnemius muscle and soleus muscle act as force to generate movement. Then the body of the athletes, with help of natural gravity, acts as resistance or load. So next. Okay, so next is sequence of movement. So generally, long jump is one of the event in athletic track and field sport, and this event is involving a combination of speed, strength, and power to jump for the distance as possible. So basically, long jump have four phases or sequence of movement, which is approach, run up, take off, flight, draw air, and also landing. Firstly, approach run up, which the athlete should sprinting as fast as possible to generate more speed momentum, because it will affect the jump distance. In the run-up approach process, the biceps and abdominal also give support to the body to make it running fast, and the extension of quadricep muscle have the role of the knee in running, and the ankle also is moved by plantar flexion moving. So next, second movement is takeoff, which is one leg need to stay on the ground to support weight before the jump. And the objective of this takeoff is to create a vertical impulse through the center of gravity while maintaining balance and control. There are many styles of takeoff we have, which is the kick style, the double arm style, sprint takeoff, and bounding takeoff. The most important is need to maintain proper body position while takeoff with keeping the torso upright and moving the hips forward and up to achieve maximum distance. So the third phase is flight through air. There are few techniques, namely the sail, the hang, and the hitch kick. But the hang and hitch kick technique are arguably effective only if you can jump further than 5 meters. The sail technique is recommended for beginners. To do the sail technique, thrust free leg in front of body as long as possible. And the takeoff, leg will follow into the same position of the free leg mid flight. Lastly, the athlete should bring the arms forward as we are trying to reach for your toes. So the last phases is landing, and it is primary to jumper not to fall back. To fall back to landing pit. The athlete should bring their heels up and head down towards their knees, and jumpers often falls forward or sideways after landing on their heels. So this phases is important because every inches will count on the distance. So that's all from me. Next slide.
Okay, so we move to the purpose of analysis. The purpose of analysis is to identify the take-off mechanism and then to identify the error in the technique. And the last one is to improve the technique in the long jump. So we move to recording procedure, which is the position of the camera and the athlete. Before we start the analysis, we briefing the subject and set up the camera at the part of the anterior and lateral. And next, we put tape at the joint on the subject's body, and the subject will do a warm-up before perform the skill. And the last one is the subject will perform the skill. Okay, next. The layout setup. As you can see here, there were a landing pit and there is a runway. The yellow emoticon is a camera and the red smiley is the subject. So that's all. Next, I pass to my friend.
Okay, thank you to my friend Siti Nur Aisha. So I will continue our presentation. So the next is kinematic properties. So kinematic properties is a study of a motion of point, object, and a group of objects without considering the causes of its motion. Okay, so there are 4 types of kinematic properties that we choose for long jump video analysis. So first is projection angle, second is range of motion, third is linear motion, and the last one is velocity. So we go one by one. Okay, the first one is range of motion. So range of motion is the full movement potential of a joint. Usually it range of flexion and extension. So here we can see the athlete and the non-athlete picture. So I had leveled the angle at their part of the joint. So we focus on the knee during takeoff, the knee joint. So we can see at the left leg for the both athlete, there had do the motion. So for example, the athlete, the angle of their knee is 179 degree and the non-athlete is 157 degree. So this is mean that the athlete make more range of motion during takeoff. Okay. So next is linear motion. So linear motion is the motion that is natural to an object moving in straight line. Okay. There are two types of the linear motion. First is a rectilinear motion, and the second is curvilinear motion. Okay. So, uh, for the certilinear motion is happen during the long jump athlete running before taking a take-off phase. Okay. During approved phase. Approved phase is a running phase lah. Okay, next is curvilinear motion is during the athlete long jump on air and before she go down to the landing, before landing phase. So that is the curvilinear motion happen. Okay, next is projection angle. So projection angle is created by the speed that is starting from the run down the runway, and the vertical velocity is a combination of a speed carried in from the run. Okay, so projection angle is happen when the athlete they run and before they take off. So we can see the projection angle during the takeoff phase. Okay, we can see that there are, okay, we can see that projection angle first is, okay, you can see at the touchdown. Okay, the next maximum knee flexion. Okay, you can see the angle of their knee, and the last one is takeoff. You can see the angle before their takeoff. So yeah, so we go to next is a velocity. So velocity is created by a speed that is starting from run down that runway, and the velocity is combination of speed carrier from the run. Okay, so how to we want to calculate the velocity? Okay, there I put the formula V equal to D per T. Okay, so V is speed, distance, D is distance travel, and the T is time taken. So this I had calculate for the athlete and the non-athlete. So we can see the athlete is higher than non-athlete velocity because the athlete use more speed. Okay, so yeah, and the time is less than the non-athlete. Okay, so we go to next is kinetic properties. So what is kinetic properties? So kinetic properties is related with the internal or external force throwing motion. Kinetic is a study of the relationship between the force system acting on a body and the change it produced in a body motion. So so kinetic properties okay. For a simple word, kinetic properties is we want to know about the force. Okay, so force. For the long jump athlete, we I had calculate for the force. Okay, that is F equal to ma, and we can see the result is the athlete get 291 Newton, and the non-athlete get 260 N. Okay. So that's all, and continue with my friends.
All right. For the strength, when the athlete have a proper training, of course, the athlete have a strength. So when the athlete have a strength, of course, for the first is have a good landing technique. When the athlete get the proper exercise for muscle and technique, the technique will go smooth and decrease the injury. It because the impact when the landing decrease, and it easier the athlete to get the best result. For the second is reduce risk of injury. Why I said that? When the athlete gain strength from the exercise, from the training, the muscle will get more strong, and it help the athlete to make a movement easily. It also help the athlete to reduce any injury and make the athlete comfortable to perform a very single technique. For the last, can achieve the maximum distance. All right. Why I said, because it easier the athlete to get the maximum distance, because the athlete know every single technique to jump. When they have a strength, have a proper technique, know the technique very well, have a power to jump, of course can achieve the maximum distance. Okay, we go to the next slide. The weakness. Right, I have 5 example. For the first, the weakness is usually for non-athlete. First is take off far from board. The objective of the takeoff is to maximize vertical velocity and to minimize the loss in horizontal velocity. Athlete or non-athlete should run fast and off the tail of the board. They should drive the leg quickly through the horizontal position and stop. Athlete should also develop strength on their takeoff leg so it does not collapse. For me, usually for non-athlete, when do the technique, most probably non-athlete will take off far from the board. Right. For the second is poor use of arm. Some non-athlete youngster throw their arm back behind them like this, and them some use a very timid low range of motion double arm flick as they jump. Get the athlete non-athlete to really stretch like they are stretching for grabbing or swing on the trapeze. When you want to jump, you have a take off from the board. Your hand must swing like this because we have a momentum to get max to get power or force to achieve the maximal um, um, what we got. Okay, for the next, looking down on the takeoff. Why I said looking down on the takeoff, because you don't know the proper technique. This is often caused by the non-athlete being too conscientious of hitting the takeoff board or being prematurely focused on trying to land safely. Try getting the non-athlete to focus on object beyond the end of the peak. Sometimes the non-athlete, when they run, want to take off, he not looking up, but he looking down, because when you looking down, you don't know uh, how high you can go like that. So the number 4 is landing with feet apart. It's very common for beginner to land with their feet too far apart, either linearly or laterally. Encourage young athlete to land in small area. In an effort to emphasize this and provide feedback, you can even try drawing a circle in the sand around their athlete feet have landed. It's normal for beginner or for the non-athlete, when they jump, they will jump with feet apart, pop, like that. Their feet like this, because if you see the professional full athlete jump, long jump, they will land with their butt, while their what we call it, while their hand will hanging and swinging, also same with their leg. For the last, slowing down and on approaching to the takeoff aboard. it usually happen to weakness or beginner because maybe for the first reason, they run too long. They run too long. So when they run too long, when they want to take off, they will slow because first tired. All right. Second, fearful to overstepping. Like I said, take off. It's not take off far from board, but take off uh, more than board. So it's very normal for for the non-athlete long jump. So this is the last slide for me. Step to maximize skill performance. If you want to perform more, please do one explosive movement, because perform an exercise, example squat jump with load and whatever and so on, because it can improve your explosive power. You can gain more power for your quadricep, hamstring, soleus, a full body part, full body part. So second, next is maximum control approach speed. Must run fast. Must run fast. Why? Why I said you must get the momentum. If you get the fast, of course you can go far, right? Hence stay outside on the hip because you want to keep discipline, because when you take off from the board, your hand is not like this, but like this. That's why I said hand stay outside from the hip. The second one, drive knee and opposite arm 45-degree angle. Like I said, this drill is normal drill for every athlete to make a good technique for run. It can help the body more balanced. When the body balance, it's easier the athlete to make a better run and jump. For the last, maintain posture through the approach. This technique also can maintain the balance of the body. Body posture is very important for every athlete. When the body posture maintained, it easier the athlete to perform a very single technique.
So the conclusion is athlete would have needed to be familiar with biomechanical principles to improve their results. The correct applications of force also important for athlete to boost their performance. The center of gravity need to be near to the front of the feet to perform a decent jump. So for the athlete to further improve his performance in long jump, he would have to needed to be familiar with the biomechanical principles such as motions, force, momentum, along with balance and stability. Motion is essential in long jump as a correct application will affect the total jump distance. The body motions, rhythms in the run-up affect the style in which the jump is undertaken. Angular momentum is enacted by the athlete as arm and leg move in opposite directions and vice versa. The swinging of the arms forward as the individual heels touch the ground boosts momentum so the athlete does not fall backwards. Another important aspect in long jump is that the correct application of force which allow the athlete to boost the performance. Force is the most effective when the athlete jumps within the common stage in long jump in a shot to leap as far as possible. Force is absorbed by the body through the ankles and knees when the athlete lands. In order to perform decent jump, the athlete should attempt to aim for a lower position during the jump so as to permit their center of gravity to be near the front of the feet. Stepping slightly ahead of their center of gravity as they run will keep the athlete more stable and fewer likely to go over. Balance is additionally needed to create sure that the center of gravity is within the correct positions, within the embark and towards the landing. When the athlete flight stage, the athlete should lean slightly back but slant forward once they land to achieve momentum. Okay, that's all from us. Thank you for much. Thank you for watching. If you have any questions, you can ask us in the comments. Assalamualaikum.